You know how we always talk about the big wins in space, like the moon landings or SpaceX? Well, there's a whole other side to that story that gets swept under the rug. These are the most expensive, most ambitious, and arguably the most useless mega space projects that never happened. And trust me, some of these are stranger than fiction. You are going to see what the plan was for the project, why it never happened, and what specific factor was responsible for burning billions of dollars and ultimately shutting down these entire space missions. Let's begin. Let's rewind to the early 1980s. Your parents, or maybe grandparents, were probably teenagers. The world was a scary place because of the Cold War. Basically, the United States and the Soviet Union were in a giant staring contest, and both sides had thousands of nuclear missiles pointed at each other. The fear was that at any moment, the world could end. In 1983, President Ronald Reagan stunned the world with an announcement no one saw coming. He wanted to build a shield, not just a shield of metal, but a shield in space. The official name was the Strategic Defense Initiative, or SDI. But the media looked at this crazy futuristic plan and gave it a nickname that stuck: Star Wars. The idea sounds like something straight out of a Marvel movie. Imagine a massive network of satellites orbiting Earth. These wouldn't be normal satellites. They would be armed with lasers, particle beams, and kinetic weapons. If the Soviet Union launched a nuclear missile at the US, this space shield would detect it instantly, lock onto it, and zap it out of the sky with a laser before it could hurt anyone. It was the ultimate defense. The ambition here was off the charts. They weren't just talking about one big laser. They wanted to use X-ray lasers powered by, get this, actual nuclear explosions in space. They also wanted to use something called brilliant pebbles. These were thousands of tiny, smart satellites that would swarm like angry bees and smash into enemy missiles. So, what was the problem? Well, money, for one. Even the lowest estimate said this would cost tens of billions of dollars. Some people thought it would eventually cost $1 trillion. That's a 1 with 12 zeros. But the bigger problem was reality. Scientists looked at the plans and basically said, we can't do this. It was considered bad science fiction. Think about the physics. You have to track thousands of missiles flying at hypersonic speeds, distinguish the real bombs from fake decoys, and then hit them with a laser beam from thousands of miles away perfectly. In the 1980s, our computers were about as powerful as a cheap digital watch today. The tech simply didn't exist. Plus, it made the politics messy. If you build a shield that makes you invincible, your enemy gets scared. They might think you are planning to attack them because you don't have to worry about them fighting back. So, instead of making peace, Star Wars just made the Soviets want to build even more missiles to overwhelm the shield. In the end, the Star Wars program was a bust. We spent billions on research. Sure, we learned a little bit about sensors and lasers, but the giant space shield never happened. The Cold War ended. The project was quietly shut down, and it went down in history as a symbol of paranoia and spending way too much money on technology that was basically imaginary. Fast forward to the early 2000s. The space shuttle had been our workhorse for 30 years, but it was getting old, dangerous, and expensive. NASA had a big problem. What do we do next? We had been stuck in low Earth orbit, basically just above the atmosphere, for decades. It was time to go further. So, in 2004, the US government announced Project Constellation. This was going to be the big comeback. The plan was to go back to the moon by 2020, build a permanent base there where people could live, and then use that as a jumping off point to go to Mars. It was huge. It was exciting. The plan involved building 2 brand new rockets. One was called Ares 1, which was a skinny rocket just to carry the crew. The other was the Ares V, a massive beast of a rocket to carry all the heavy gear, the lunar lander, and the supplies. The crew would launch in a capsule called Orion, meet up with the lunar gear in orbit, and head to the moon. It was like a remix of the Apollo missions from the 60 seconds, but with better technology. Billions of dollars started flowing. Thousands of engineers got to work. But almost immediately, things started going wrong. The skinny rocket, Ares I, had a serious vibration problem. Engineers called it pogo oscillation. Imagine sitting in a chair that is shaking violently, up and down. Now imagine that chair is strapped to a bomb. That's what the astronauts would have felt. The vibrations were so bad they could have destroyed the rocket or injured the crew. Trying to fix these problems cost a fortune. NASA was trying to design 2 rockets, a new spaceship, and a lunar lander all at the same time. It was too much. The schedule kept slipping. The budget kept exploding. By 2010, they had spent somewhere between $9 and $11 billion. When President Obama took office, he had a committee look at the project. Their conclusion? It was behind schedule, over budget, and lacking in innovation. Basically, it was a mess. So, in 2010, Project Constellation was cancelled. Just imagine that. Spending $11 billion, enough to buy endless amounts of video games, houses, or cars, and getting almost nothing to show for it. No moon base, no Mars trip. However, it wasn't a total waste. The Orion capsule, the little ship the crew sits in, was actually pretty good. NASA kept that part. Today, that capsule is being used in the new Artemis's program. So, Constellation died, but its purpose lives on, helping us try to get back to the moon again. Now, let's talk about a dream that every sci-fi fan has had. What if going to space was as easy as flying on an airplane? No dropping rocket boosters in the ocean, no complicated stages. You just take off, fly to orbit, and land on a runway, refuel, and do it again. This is called single stage to orbit, or SSTO. It is the holy grail of rocketry. In the 1990s, NASA thought they had cracked the code with a project called the X-33 Venture Star. The X-33 looked incredibly cool. It didn't look like a normal rocket. It was a wedge-shaped lifting body. The plan was to build a prototype, the X-33, to prove the tech worked, and then build the full-sized Venture Star. This vehicle was supposed to make space travel cheap and routine. To make this work, they needed some magical engineering. First, they used a special engine called an aerospike. Normal rocket engines have that bell shape at the bottom, right? That shape is great for space, but not efficient near the ground. An aerospike is shaped like an upside-down bell. It uses the air pressure around it to change the shape of the flame, making it super efficient all the way from the ground to space. But the real problem was weight. To get to space in one single piece, your ship has to be almost entirely fuel. The structure of the ship has to be impossibly light. If it's too heavy, gravity wins and you don't go to space. So, the engineers decided to build the fuel tanks out of composite materials, basically super strong, high-tech plastic and carbon fiber instead of heavy metal. These tanks had to hold liquid hydrogen, which is incredibly cold. And that is where the dream died. Making a tank that is light as a feather but strong enough to hold super cold fuel under insane pressure is really, really hard. During testing, the tank started to fail. The composite material would crack and split apart. They tried to fix it, but the physics were just fighting them every step of the way. In 2001, after spending about $1.3 billion, NASA pulled the plug. The X-33 never flew, not even once. It sits in a hangar somewhere or in pieces in a museum. It's a sad reminder that sometimes, even if you have a cool idea, the laws of physics just say no. We still don't have a single stage to orbit spaceplane today. We are still stuck using rockets that drop off parts as they go. Next up, we have a project that sounds like it belongs in the year 3000. It wasn't about sending humans to space. It was about sending the ultimate robot explorer. This was Project Prometheus and its main mission, the Jupiter Icy Moons Orbiter, or JIMO for short. Scientists are obsessed with Jupiter's moons Europa, Ganymede, and Callisto. Why? Because underneath their icy shells, there are massive oceans of liquid water. And where there is water, there might be alien life. We aren't talking little green men, but maybe alien microbes or fish. The problem is, Jupiter is far away. Sunlight is weak there, so solar panels don't work very well, and chemical rockets run out of fuel quickly. If you want to explore these moons properly, you need power, lots of power. The solution? Nuclear power. JIMO was going to carry an actual nuclear fission reactor on board. This reactor would generate huge amounts of electricity to power an ion drive. An ion drive uses electricity to shoot out gas particles at crazy speeds. It's a very gentle push, but it can keep pushing for years. This would let JIMO hop from one moon to another, scanning deep under the ice, hunting for life. It was the perfect scientific machine. It would have revolutionized how we explore the solar system. Imagine a robot that never runs out of battery and can fly wherever it wants. So, why don't we have it? You guessed it. Money and fear. Building a nuclear reactor that is safe to launch on a rocket is incredibly expensive. We are talking astronomical costs. The budget for this project started skyrocketing into the billions before they even built a single screw. Also, around 2005, NASA decided to focus all its money on Project Constellation, the one we just talked about. They couldn't afford both. So, they killed the nuclear robot to pay for the moon rocket, which also got canceled later. Ouch. Billions were spent on designs and research for Prometheus, but no hardware ever left Earth. It's one of the biggest what-ifs in history. If we had built JIMO, maybe we would have already found life on Europa by now. Instead, we are still waiting. So, which one of them do you think was the most tragic waste of potential? Let me know down in the comments below. And don't forget to like, subscribe, and hit that notification bell for more interesting space videos in the future.